Hello everyone, thanks for joining Cyber Skyline Live. I'm Franz Payer with Cyber Skyline and I'm here to help you learn cybersecurity. This is going to be our first episode of this new series because summer ended. We're no longer summer live. We're now just live. So this will be the first in this new series. We're doing everything the exact same. We're just changing the name of the series. But with that in mind, we run these episodes for you, so please stick to the end to vote in the poll for our next topic. If you haven't already, please make sure to sign up for the National Cyber League fall season. Regular season registration closes tomorrow, October 8th at 11:59 p.m. Eastern. So please make sure that you are signed up and please make sure that your friends are also signed up as well. This week, we're going to be covering SQL basics, and I'm going to jump straight into my slides. But in the meantime, please let us know in the chat where you're from. And as we go through today's episode, feel free to ask any questions in the chat. I will get to them when we get to natural stopping points in the session. But without further ado, I'm going to switch my screen. All right, so let me take a look at where everyone's coming from. Got people from Raleigh. I think there'll be a couple more, but I got a stream delay. So let me just go into the slides here. So before we can go into what SQL is, we need to cover what is a database. And I think this can be a scary concept for some people, but you can actually really just imagine it as a giant spreadsheet. A database is an interface that allows you to access a store of data. And by interface, I just mean that it has like easy ways for you to go and access the data. So let's just say, for example, you had a giant spreadsheet of user accounts. In one column, you had the name of the person. In one column, you had the email address. In one column, you have the password. And you wanted to find someone with a particular username and password, right? If you're doing that in a spreadsheet, it's not very easy to do that in a normal spreadsheet. In a normal spreadsheet, you can basically only search for like one value at a time. But in this specific instance, we're actually looking for two values that are combined, that are in the same row at a time. It's not so easy to do that in a spreadsheet. And databases help you do complex queries. That example I gave is a very simple query example, but you can look and ask your database for more complex things. Say you want to find people who like logged in after a certain date and you had another column for when they last logged in. All of those things can be accomplished with databases. Now there are different databases and each database, they offer different trade-offs. Some are easier to use in terms of like, as a developer, how easy is it for you to write a command to make a modification to the database? Some databases are easier to use than others. What about the efficiency? Maybe you have a database which is much faster than another database at storing very specific data. So for example, there are some databases which are much better at storing time data, some databases which are much better at storing geographic data like GPS coordinates, being able to like run queries about like, tell me how many other items are within this distance from a specific GPS coordinate. Those types of queries might be more efficient with specific databases, and that's why they have different databases. They also come with different reliability guarantees. So one database may be faster. It gives you faster response times, but as a trade-off, if the power goes out, there's a chance that you might lose some data. In some circumstances, that's okay. In others, it's not. And so the developer will typically choose the database that makes the most sense for their specific application. And in some applications, there might be different databases because these databases have trade-offs. You might have one database for one purpose and another database for another purpose. So, there's nothing that stops you from using multiple different databases. It's really up to what you prefer. Now, the old school, the most common database out there is a SQL database. And SQL refers to the structured query language. And there are a lot of different types of databases that use this standard language, and you can choose a database that makes sense for you. Some of these are paid, some of these are free. So for example, MySQL here, MySQL is a free database, Postgres is a free database, but there's also MS SQL, that's Microsoft SQL Server. There's also Oracle SQL. Those are paid databases. You have to pay for a license to access those databases, and they have different trade-offs. You're probably going to be, at least before you get a job and you work in an enterprise environment, you're probably going to be playing around with MySQL and Postgres because they're free. But both databases, MySQL and Postgres, they will use SQL, so the same commands should theoretically work on either type of database. The one caveat here, though, is that MySQL and Postgres and all the other SQL databases, they will sometimes create their own extensions on top of the language, which just add-ons that are only available for that database, not for other databases. There are also NoSQL databases, and this basically just refers to the broad category of databases which don't use SQL. And that common ones include MongoDB, Redis. There are dozens of other databases that fall into this category that I just don't have time to cover today, but they don't use this query language to access their data. They use a different language. Most of the time, it's a specific language for that specific database. So SQL itself is the structured query language. It's a standardized language so that you can use the same language in multiple different databases, any SQL compatible database. And specifically, it's used for managing data in a relational database. And so I mentioned before, you can imagine databases as a sophisticated spreadsheet system. I'd say that relational databases are the most one-to-one comparison of that. You literally define a table inside a database, and you can imagine a database as your big spreadsheet. If you have an Excel spreadsheet, let's just say as an example, then you might have multiple different sheets inside your spreadsheet. Each one of those new sheets is effectively a table in that one database, right? So there's a very one-to-one translation in the way that relational databases and SQL databases can be characterized with Excel spreadsheets. And like Excel spreadsheets, a SQL database will have columns, and you in each table, and the equivalent in this in a spreadsheet is a sheet, you have at the top typically headers, right? And so when you define a table in SQL, there will be defined columns that will say, hey, in this column, this is someone's first name. In this column, this is someone's last name. In this column, this is someone's password, and so forth, right? You define the structure of that table just like you would have headers in a spreadsheet. And a very, very similar concept. And what you can do with SQL is a lot of things. You can use SQL to obtain records that match your search criteria. You can create new records. This is called inserting into the database. You can update records. So basically just make a modification. You can delete records. You can create new tables and more. You can see the comparison here again with a spreadsheet, right? In a spreadsheet, you can copy entries out of your spreadsheet or visually obtain those entries in your spreadsheet. You can always add new rows. Adding a new row in a spreadsheet is the equivalent of adding a new record in a database. You can update records, right? So just like how you might, make a modification to a cell in a database, you might make a modification to a record or to a row in a database. You could also delete, right? You can delete a row in a spreadsheet. You can delete a row in a database. But SQL is very powerful in the sense that it allows you to do a lot of customization in specifically what types of queries you want or how you want to update your data. And more importantly, a spreadsheet requires you to update data manually, right? If you want to update 10 entries, you have to manually type in those 10 entries. SQL allows you to update records programmatically. So if someone creates a new user on your website and you're using a SQL database, when they enter in their user information, you don't, as the developer, you don't have to manually copy their entry into a spreadsheet. You take what they inputted on your form, and then you write a SQL query. That's a SQL command effectively, which will create the new user in your database, right? And so you write that one time, you write the code that takes the input from the form, converts it into a SQL query, and then execute that SQL query in the database to insert that new record. You write that one time and it will always happen. And so it's a way to automate this entire process. So I'm going to dive into the common SQL commands. I'm separating these into verbs and adverbs. This isn't how I think this is like. This is not like the official way that they classify these terms. I like classifying it this way because it makes it a little bit easier for me to understand. But basically, you have these verbs. These are basically actions. This is what are you trying to tell the database to do? And those actions can be modified by the second list here, which I called adverbs, right? Just like how an adverb modifies a verb. The second list here provides specific modifications to the commands that you want to execute. So let me go through some of these examples here. So we have select. This is specifically looking up data in your database. There's update, which self-explanatory, makes an update. Delete, also self-explanatory. Insert into, this is 2 words, but it specifically inserts data into the database. And then there is drop table. I guess I could add here, there's also create table. But like I mentioned, tables are effectively different sheets in your spreadsheet. So you can have a database. In your database, you might have a users table. And let's just say we're making a social media network, and hopefully one that that doesn't go down for 6 hours in a day. And you might create a table that has posts, right? And so inside your posts table, you might store the URL for the post. You might store the text of the post. Maybe there's an image, so you store a link to the image. Maybe you have another table called likes. The likes will have an indication of the user who made the like and the post ID, right? So you have these multiple different tables, which are effectively multiple different spreadsheets in your multiple different sheets in your big spreadsheet. And so you can you can automatically, or programmatically create and delete different tables within your database. Just like how you can delete and create new sheets in your spreadsheet. In terms of our adverbs, here's what we got. And these aren't all of them. This is not exhaustive. These are just common ones. There's the where command. So where will allow you to specify a criteria to match your command. So let's just say we want to specifically only get records when we get users with a specific requirement. So let's just say we want to filter all users with a specific email address. We could do a select and then say where, and then we can say email address equals, and then your specific email address there. That lets you do a filtering. Like is used in conjunction with where in the circumstance where you don't have a strict matching. You want to maybe be a little bit more flexible. So let's just say you want to throw in a wildcard. Maybe you want to do partial matches in your database. Maybe you just want to say, maybe you're making a search page and you will take their input and then you will say, give me all the records that have this input as the beginning of the title, for example. That's where you can use like. From lets you specify which table you want to be looking at. Limit just gives you a max number of results that you want to return. Set allows you to specify which values you want to update in the database. Values goes with set, and so set specifically says which columns you want to, set and values can be used together to specify which columns and which specific values you want to update. You have and, which if you use that in conjunction with where, you can have multiple different requirements. So as an example, let's just say I want to get a user where the username and password match. So that's where you would use and it's not just limited to where you can use in other queries. Or is it accomplishes a similar function of allowing you to have multiple different conditions, but and requires both conditions to be true. The username and the password both need to match. If one of them does not match, it doesn't return the result. Or allows you to say if one or the other matches, that's okay. So only one of the two need to be true. Maybe you're looking for people who, let's just say we want to find users who logged in the past week or created an account in the past week, and maybe they didn't log in after they created the account because we want to send them some sort of notification, right? You can write a query that says get all users where their last log in was in the past week or they created their account in the past week. That's why you would use or. So let's see some examples because that might be a little bit hypothetical. Yeah, so I'm going to actually switch my order here, but let's go through some examples. Very, very basic example here is let me just get all of the records in a table. And so this is the select star from users. This specifically says return all of the users in the table, right? So if we have 1,000 records, 1,000 users, if I run this query, I will get all of those users in the table. Now, if you want to restrict that, I mentioned you could use where to specifically filter your results. In this second query here, we are saying select star. So this is still select everything. And actually, let me clarify this a little bit. The star is specifically referring to the columns. So when you say select star, you're specifically saying select all of the columns, get all of the records for all of the users. You could filter it down. You can specifically say, let me get just their email addresses, in which case you would say select email from users. So the star here is referring to which columns you are retrieving. So we're saying select star from, and then users is the name of the table that we have here, right? And in the previous example, that's where this command stopped, right? It was saying, get me all of the columns for all of the users in the users table. Now we are saying select star from users where email equals, and then we have an email address here. So this where component is specifically adding a filter, and it's saying that the email column in the table has to equal, and this is admin@cyberskyline.com. Now, if for whatever reason there were multiple users with that email address, this request would return all of those entries with that email address. If there were none, if nothing matches, you just get nothing, right? So a couple things to note from the way that this is the syntax works. The email here, you can see here it's in lowercase and it doesn't have those quotes around it. That's because that is the name of the column. So you don't need to put the name of the column in quotes, but any specific value that you want to enter, whether that is inserting into the database or that's part of your search parameter, those values, if they are text, they need to be in quotes. And so that's why you see the command saying where email equals, and then you have the quotes with the text for the email address. Another thing here is like, when you want to specify which email address it is, you use equals to signify that, right? So that's why you have email equals, and then you have admin.cyberskyline.com in those quotes. In both of the examples, the first and the second, you see there's a semicolon at the end, and that's the case for the rest of these. For the top three and the bottom three, I didn't include them, but in general, you want to have a semicolon at the end of your SQL command that tells the database that this is the end of your command. Some databases will be flexible; they will allow you to run the command without the semicolon, but it's generally better to have the semicolon at the end so that the database knows this is the end of your request. Let's go on to the next example here. We have select star. So give me all of the columns in the users table from users where, and before we only had a search for the email, but now we are asking for where password, so where the password column is equal to the text my password, and the email address is equal to admin@cyberskyline.com. So in this circumstance, before, the second example here was only searching for users with that email address. This third example here is searching for records where the password and the email address both match. Now I will note here that this is clearly an insecure database because we're storing the passwords in plain text. I'm just using this for demonstration purposes, but in general, you do not want to be storing passwords in plain text in your database. And we will be doing an example later today, which will show you exactly why that's the case, why you should not have the passwords in plain text. But for this example, you might see this example as a query that might get executed when someone tries to log in. If you're trying to log into a website, you enter in your password, you enter in your username, and then when your request makes it to the server will then query the database, and the query that the server makes might look something very, very similar to this. It'll take the password that you entered and the email address that you entered, and it will attempt to find any records in the users table where your password and your email address match. And that's how it's logging you in. It's making sure that, if you just type in any random email address, it won't let you in because the password and the email address must both match. In this next example, we have an example of inserting data into the database. And so this is pretty simple. It's just insert into, and then after insert into, you specify which table you want to insert your records into. And so we want to insert into the users table because we want to create a new user. And following that, in parentheses here, you are specifically seeing the columns that we are going to provide as input into the table. You can see that there's password, comma, email. And so in this circumstance, there must be a password column and there must be an email column. And we're going to specify our values in that order. It's going to be password, then email. If we swap the order around, it would be email and then password. So after those parentheses, you see then immediately values, and then there's more parentheses, and then inside there is my password in quotes, comma, admin@cyberskyline.com in quotes. So in this example, because we said we're gonna, because we said users and then password, comma, email, we specifically said we're gonna give the password first and then we're gonna give the email. If instead we said email, comma, password, then we would also need to swap the order in which we provided the actual values. You can choose to opt to not specify the column order, in which circumstance, when you specify your values, you need to make sure that your values are in the same order that the table columns are structured. Because the way that we have it right now, we get to define the order that we want to put the data in. But if in the absence of doing that, the database will assume that you are inputting the data in the standard order that the table has been laid out. Our next example here, we're creating an update, or we're doing an update. Specifically, we are setting a new password for the admin@cyberskyline.com user. So the way we'll do this is we'll use the update command and then the users table. And now we're saying set. So we're specifically setting values, and we're saying set the password column equal to new password. So whatever is in the password column, we're replacing it, and we're sticking in the value new password, and we're saying where email equals admin@cyberskyline.com. And so we're finding all the entries where the email address is admin@cyberskyline.com, and we're changing the password and we're updating it to be new password. And then our final example here, we're deleting a user, and in this case, we're saying delete from, and we specify then the table. We're deleting from the users table where email equals admin@cyberskyline.com. So we're deleting any records in here that have an email that is equal to admin@cyberskyline.com. So you can use the where clause not just with the select command, but you can also use it in the delete command as well. It's going to take some time to get used to memorizing all the different commands and when do you need to, well, like what order do you put these different commands in? Select always comes first. Select comes before where. You don't put where at the beginning. I think the best way to learn this is just by looking up examples online. You've got some examples here. I'll do some of the demo. If you have a question about how you would run a specific query, just ask in the chat and we'll take a swing. Hopefully I know how to do it. If not, we'll look it up on the internet. But I'm gonna go back one more slide and go over some special characters. You saw us using the asterisk. That's specifically used to match all columns when you're doing a query. There's also the %sign that is used for doing searches where you're not doing an exact search. So the %sign will match 0, 1, or more characters. And so it's kind of like a wildcard in the sense that you can match nothing or as many additional characters as necessary. There's also the underscore, which is very similar to the %sign, but it will specifically only match one character. And so we'll see this come into play later today. I just wanted to give you a heads up about what these mean. You don't have to know it right now. All right, so let's talk about SQL injection. I gave the example earlier about there being what happens if you have a login panel, and and that's this third example here. When you are running a query to check to see if someone has the correct username and password, you would run a query like this. You would say select whatever from the users table where password is, and in this case, in the quotes, this is the password that was entered into the form. And then the email address is also the email address that's entered into the form. So the way that SQL injection works is it's asking the question, what if the user, instead of just putting in a password or putting in their email address, what if the user were to actually input valid SQL queries, like a valid SQL command? And so that's what you're seeing here in this example. The normal query here is exactly what I showed you with the password or the email address, but instead of a user being nice and typing in their normal password, what if they typed in the SQL query? And in red is specifically, I'm highlighting what they would have typed in. So normally a user would type in my password, right? Just my password, no quotes, just my password. And then the program here is just taking what the user typed in and putting it in between these quotes. So you can see here, password equals quote, my password, end quote. The user did not type in the quotes. The program specifically took in what the user typed in and put it in between those quotes. In this example here, the user in red typed in my password, but then they typed in quotes. And then after they typed in quotes, they typed in or, and then they typed in 1 equals 1. So they typed, and the reason why they typed 1 equals 1 as quote 1 quote equals quote 1 is because this query, their input is specifically being added in between two quotes already, right? Look at the first example here. Quote my password quote. If the user makes an input, whatever that input is, this quote at the beginning and this quote at the end are still going to exist. And so what's happening here is the user is typing in my password quote. This quote here will match with this quote. And so this query is specifically going to check select star from users where password equals my password, or 1 equals 1. And these quotes here are specifically made so that the start and the end of the quotes line up. They still need to be in alignment, because if they're not in alignment, this will cause an error, which will cause the entire command to fail. And so what's happening here is this quote 1 quote is specifically referring to the text 1 rather than the number 1, and it's checking to see if that's equal to the text 1. And that will always be true. Text 1 will always equal text 1. The string 1 will always equal the string 1. It's always going to be true. But the reason why the quotes are here is specifically because the hacker, the malicious person, they need to find a way so that this end quote that's going to come after what they typed, this needs to line up to a previous quote. If you have an odd number of quotes, a quote is specifically delineating the start or the end of some text. And so if you have an odd number, you have a mismatch. Every single end needs to every single start needs to have an end. So if you have an odd number, there's one pair there's a pair that isn't being made. And so that's specifically why in this example the hacker had to add these quotes here so that the entire command is valid. And you can see I specifically said here, the user enters my password quote or quote 1 quote equals quote 1. Because there's this quote at the beginning. This quote at the beginning will be inserted before the M in my password, and this quote at the end will be inserted after this 1 at the end. And so what ends up happening is that instead of doing a normal password lookup, the query is going to check to see if password equals my password. Let's just say, for example, that admin at cyberskyline.com, their password is not my password. It doesn't matter that the password didn't match, because we're checking for the password match or 1 equals 1. And 1 equals 1 is always going to be true. And because we're doing an or and not an and, only one of these two things needs to be true. The password needs to match or 1 equals 1. And because 1 equals 1 will always be true, the password is irrelevant. And so what this will do is this will effectively log in the user as the admin without even knowing the password. And that's why SQL injection is so dangerous, because if you're vulnerable to SQL injection, someone can log into your account log into your website without knowing people's passwords. They can extract a lot of data from your database. And so it's very, very important that when you write SQL queries in your software, you actually do checks to make sure that that there are no SQL queries inside the user input, right? And there are a lot of different tools and mechanisms to go and do that. I'm not going to get into that today. It's a little bit out of scope, but keep in mind that there are different frameworks and tools out there to help you make sure that you do what's called sanitization. You're sanitizing the user input to make sure that something like this doesn't happen to your login page. So with that, I know that was a lot of information. I'm going to go and answer some questions, and then we're going to jump into the demo. Okay. So there is a lot of comments here. I don't see too many questions. I think we have someone here asking for this seems so JC is asking, much of this appears to be similar to what I can do with Access. What is the difference? Well, Access is a database. So hopefully that answers your question. Yeah, Access is a database in its own right. I haven't used it myself, but that's why it seems very similar. It's because they do the exact same thing. And Manny's asking, I'd like to see a session in the future on how to prevent SQL injection. Great topic. I'll put that in the queue. I think we'll come to that at some point in time. All right. So if you all have any additional questions, go ahead and ask them in the chat. I'm going to do a demo, and I will show you how to play with the database, how to insert these records normally as a developer, and then after that, we're going to go through an example of actually doing a SQL injection on an application. So I'm going to switch over, and we'll do this demo. All right, I'm going to log into my system here. Hopefully I type in my password correctly. All right. I forgot that I changed my password on the previous episode and I didn't reset it. So I'm glad I was able to log in. It looks like there's some questions. So before I dive into the demo, I'll answer some of these questions here. Jeff is asking, can you do the same thing with the user or the email? Yes. It doesn't matter. Well, you could, but you need to think about what the ramifications is of your result, right? You can do SQL injection on any field, but if you're a hacker and you want to log in as someone, and you get to choose which one of the fields you make optional, whether you make the password optional or you make the email address optional. If you want to log in as a specific user, you probably want to specify which user you want to log in as and then make the password optional. In theory, you could log in as anyone with that password. You could do the reverse, right? You could say password equals my password, and then email address, the email is 1 equals 1. And then if there is someone with that password, you would log in as them. It's a little bit more wonky that way, but I suppose you could do that as well. All right. So let's play with a SQL database. And the database I'm going to use today is called SQLite. And I'm using SQLite for a couple of reasons. One reason, it's free. Another reason, it's easy to install. If you don't have it installed on Kali, you can do sudo apt-get install SQLite 3. So let me just show you that command. Sudo apt-get install SQLite 3. I'm not actually going to run this update right now. This is not the time to be running an update. But that's the command that you would use if you need to install it. And it's very, very quick and simple. So I would highly recommend using SQLite as your starter. And the way that we are going to start a new database is we type in SQLite 3 and then the name of the file which will hold our database. So I'm going to call this test.sql. So now we have a command line inside the database. So keep in mind, this isn't like normal Linux command line. We're inside a SQL terminal, and so we need to type in SQL commands here. So I will start by creating a new table, and so the way that I need to do this is I need to say create table. This is specifying that I'm creating a new table. And let's say we're going to create a table called users. And inside the users table, there will be a username. And for each column in the table, you need to specify what type of value that column holds. A very common example would be you might be text, right? That's going to be very common. I need to do a quick search because you can also create number values. So let's just say I want to create a username column that will hold text. I will also want to create a password column that will hold text. And then let me just say I create an ID. So ID, and then I will call this int. And so int refers to integer. So this will specifically only store numeric values. And then I'm going to end this with the semicolon. So let's break this down here again, right? So create tables. We're creating a new table, which is called users. And then this table in parentheses will have a username column, which holds text, a password column, which holds text, and an ID column, which holds integers. Integers are numbers that don't have decimal points, if you forget. So this will create the table. I'll hit enter. And a good way to check in SQLite, and this is specifically a SQLite command, is .tables, hit enter, and this will say, this is my users table, right? It exists now, so I can see that there. So now we have an empty table. So we should add something into our empty table. And so we'll type in the insert command. So let's say insert into, and we want to insert into the users table. And there's two ways that we can go about doing this. So let me pull up my notes real quick. All right, so we can insert into the users table here, and we can specify the order in which we would like to put in these values. So when I defined the table, I said username, password, and then ID. If I want to provide my values backwards, I can do this. I can say, I want to specify my values ID, password, and then username. And so let's say we have ID 0. Password is my password. It needs to be in quotes because this is a text value. So 0 here is not in quotes because it is a number. My password here is in quotes because it is text. It's a string. And then the username is also going to be a string. And then we need to end with a semicolon. If I hit enter now, we will have a new user added in there. And I'm going to create a second user. This time, I'm going to follow the standard order of the columns. So I'm not going to specify ID, password, and username like that. I'm going to say this is user 1. And I'm going to, it's user 1. And the password is going to be user pass, and then the ID is going to be 1. Oops, I made a typo. I have to insert into users. So now we've created that new user. Now the order matters here, right? Because if I swapped it, so let's just say that I wanted this to be so the order is username and then password and then text. So let's just say like this was, instead of inputting it in that order, I input it as my password, and then my username, and then the ID. You're going to see that this will be wonky when we look at the table. It's going to be flipped. I think, though, that if you try to input data and then the types don't match, so let's just say I do 1, 1, oh, that might work. So you got to be careful with this stuff. Make sure that you know exactly what order your data is being inserted into, because it might accept your data, but you might have accidentally put the password in the username field or the username and password field, which is what you're going to see in a second. So now that we've entered all of this data into the database, let's go and view it. So I'm going to say select star from users. So this is specifically going to give us all of the columns and all of the entries in the users table. And you can see here that we have admin, my password, user 1, user pass, not really password, not really username, and here's the 1, 2, and 3. So let's show you how this is actually flipped. So let me specifically select, and I only want to get the username. So let's say select username from users. You can see here that the username from the first user is admin, the username from the second user is user1, and the username for the third user is not really password. So like this is this is the password that we entered, but it is showing up in the username. So this is not really the password. This is actually the username here. And then there's that one there that we left. Oops. All right. Now let's filter our results. So let me only get the username of users who have the password user pass. So this command is getting the username of all users where password equals user pass. If I hit enter, you can see only user1 matches that criteria. We could come here and we can say where password equals user pass, and then let's see what happens if the name matches properly. So this is basically a login query. Select username from users where password equals user pass and username equals user1. We get the same result. But let's just say the username was incorrect. Let's just say the username was admin. Nothing. It's empty, right? So you can see here that you specifically want to you can specifically query to limit your search results. This is very, very common for doing logins here. And the reason why I'm harping on logins so much is because that's going to be the example that we do for our SQL injection attack. So if any of this seems confusing in terms of like what's the process that occurs when you do a query to obtain records, when you do a login request, let me know. I want to make sure that's thoroughly explained. But so far you've seen how to create a new table. You've seen how to insert results. So you're able to obtain the results. All of the results get a specific column from the table. Let me even go get the ID instead of getting the username. Let me get the ID. Let's get the ID for user one. So you can get specific columns from the table, matching specific search parameters here. I'm also going to show you how to delete an entry. So let's do a delete from, we're going to delete from users where, this where, when you do the delete, works exactly the same way as when you do the select. The difference is that select is going to return the results and delete is going to delete the results. So make sure you don't get those two confused. But we have delete from users where, and let's just say where ID equals 3. This is this 1, 2, 3 entry that we created. And you see here, I forgot my semicolon, which is why it didn't execute right away. So I have to type in my semicolon and then hit enter. And now it's deleted. So let's confirm. Let's see, is it actually deleted? Because we have a small table, we can actually print out all the results and see. All right, so before, when we ran this query, we got 4 results: admin, user 1, let's just do ID. ID 0, ID 1, ID 2, ID 3. Now we only have ID 0, 1, and 2. So you can see that it got removed from the database. Now let's do a query where instead of using and, we use or. And so I can say select username from users where password, or where, let's just say where ID equals 1 or ID equals 2. So this will give us 2 results. And we need to remember the semicolon. There are our 2 results. So or specifically requires that either of these 2 options is true. In the case of user 1 is ID 1, and then this not really password is ID 2. And so they both matched because one matched ID 1 and the other one matched ID 2. You can continue adding more and more of these. I can say or ID equals 0. And now we have 3 results here. So you can just keep adding and modifying this. Now, what if we want to do a partial match? So let's just say that we're doing a search. I want to find all of my usernames where username, and let me just say I'm looking for things that, let's just say I'm looking for any usernames that have user. So I can say user, and then, sorry, this is, I have to pull up my notes here. Okay. So we can say where user name, and instead of doing the equals is specifically doing a direct, like a strict comparison of the values. I can say like, and then I can specify a pattern. And the pattern I'm going to specify is I want to get all users that have user in the username. We should only have one in this database, which is user 1. So I'm going to run this right now, and we'll see. Oh, I used the wrong. Character. Instead of doing the asterisk, I need to be doing the %sign. From the previous notes, the % is the wildcard for the like operator, and so now we see user 1. Let's create another user so that we can get 2 results instead of 1 result. And so I'll just do a quick insert into users, values, and then we are going to create user 2, pass, user pass 2, ID is 3. Insert. These need to be in quotes. All right, so now we've created a new user 2, and if we run this search for anyone that has user in their username, you see user 1 and user 2 this time. So this %sign allows us to do these wildcard searches in the query here. All right, so I'm going to pause here for some questions, and then we'll move on to doing some SQL injection. Okay. So Nick is asking, how would you link your database to an application, and how would you find your database's ID? So this is very much going to depend on what your technology stack looks like. So if you are, let's just say you're coding in Node.js. That's what we create Cyber Skyline with. There are what are called libraries or packages. Basically, these are some other people's code that you can import into your project, and their code will provide you with a way to connect to the database and run these different queries. So let me do a quick Google search and show you on here. So if I do Node.js, SQL, there's this MySQL project that you can install, and then when you install it, this is the code that you would write. You would create a connection to the database, and then it looks like you call the connect function, and then when it connects, here you can write your logic after you connect into the database. And so in here is where you could write code that says, hey, insert X, Y, and Z into the database, or delete X, Y, and Z from the database. There's no standard way to do it, right? Because what I'm showing you here is an example of how you might do this with MySQL in Node.js. But what if you aren't using Node.js? What if you're using Python? Or what if you're using Ruby? Or what if you're using PHP? Each one of those different languages has different modules, different libraries, different packages, whatever the term is in that language, to access your database. But generally, this is how you would do it. Now, typically what will happen is you'll use something like you'll use the command line like I did with this SQLite database, and you will manually create the database that way to get it started. Although you might write a script which will automate that process for you. But you would create the database, and then at that point you would have the database name. When I did it with SQLite here, I created a test.sql, and so my database's name is test. And then I can even look here, Node.js SQLite, and here's a tutorial here. And basically what you would do is follow their instructions here. This is an example of how to create a new table using SQLite in Node.js. You import SQLite 3, you specify a new database. This database connects in the RAM rather than, so this is like this is saving in short-term memory, right? So this is not going to be saved on your computer. And then here's an example of like how you would execute a command. This will create a database, it'll insert some values, and then it will retrieve those values. So it's going to be very different depending on your configuration and your coding language. All right, so let's jump into actually running SQL injection. I have a challenge here from the gym. This is the medical clinic. This is the hard web application security challenge. And I'm going to gloss over a little bit of this process due to time constraints, but we're going to go through the process of SQL injection. So when you click on this website, you open a new tab. This is what you get. Immediately when you're looking at doing SQL injection on a website, you are looking for anywhere that the user can type in some sort of text that the website will do something with. And so login pages are good places to look. Search queries like search bars, those are good places to look. I would recommend those as the top 2 places to look if you're trying to do a SQL injection on a website. In this case here, what we have is this is like a directory for people within this hospital network, and you can search for them. And so if I want to search for A, I hit enter, I get everyone who has A in their name. That's what it's actually searching for. And if I searched for B, I guess I would get everyone with B in their name. I guess no one has B in their name. C. There's everyone with C in their name. All right. So this is what the login page, what the search page is doing, is just taking your query and checking to see who matches. When you are doing a SQL injection, you want to be asking yourself, what does the query look like? Like when I type in this command, how is that going to be used in the SQL query that goes to the database? When I'm looking at this, I'm thinking about it. I'm imagining that this is definitely going to be a select statement because select is searching for results. And then it's going to be searching in some table. I don't know exactly what the table's name is, but I need to probably guess what that table's name may be. Then after I guess the table, in addition to the table, there's going to be a where, right? So it's probably going to be select something. I don't know what fields that this is querying on, but select something from some table where, and then it looks like it's searching by name. And so it's going to be something where name equals, or in this case, it shouldn't be equals, it should be like, because we're not doing a direct comparison, right? When I type in A, this gives me all of the results with people who have A in their name rather than A in their name rather than anyone who just has the name A. So this is having like in there, most likely. I'm guessing, right? And Harbor is asking, is this blind injection? This is semi-blind injection. The way that I'm approaching it right now is fully blind. You do get some error messages, which might help you when you start running your queries. But I'm approaching this as a blind injection right now. And so I'm kind of guessing what this query looks like. And let's just go back to the home and let's just see what the question's asking us for. So I'm going to do some of these easier ones where it's asking, what is like the name of the only orthopedist? So if I am imagining that there is a like statement being used and it's using those percent signs, what if I just type in a space? Because all of those results I saw there's a first name and a last name, and that means there's a space in between the two. So if I just type in a space, well, everyone should have a space in there. And so sure enough, if I type in space, I get every single person, well, what it appears to me at least to be every single person in the database. And this question is asking the only orthopedist. So only orthopedist, here it is, it's Tracy Gill. All right, I'm gonna input that in. And then it's asking for some other information, Katie Kane's profession, how many people are in the registry. I'm gonna skip all of that. I'm gonna go to the interesting one, which is, what is the name of the person who has a password of gray blob? So this tells me that there are passwords being stored in there, and that password is likely the name of a column in one of these tables. What I'm going to do is I'm going to go back and I'm going to imagine what does this query look like, and I'll do this over here. So I'm going to type in what my thought process is. I'm thinking that this is going to look like a select star, or I guess select something. I don't know what it is. But let's just say it's select star from, and then I'm going to need to guess the name of the table. I'm going to guess users. And if that doesn't work, I can guess something else. You can run, if you can trigger some errors in here, sometimes you can get it to tell you the name of the table. So if I just start, I'm going to assume that quotes are being used in here. So if I just like do some quotes, I can see here error, Sqlite error, and then it's kind of hard to read, unrecognized token, and then it keeps going, quotes. So what if I just did like misuse, not an error. So you can play around and you'll get all these different error statements to narrow down like what's actually going on here. But in terms of this query, I'm imagining it's going to be something like select star from users where name, and I'm guessing name as well. This is kind of a guess. Where name like, and if I had to assume the way this would work, it would be like, and then it would have these two wildcards. And then in between the two wildcards, this is where my search query, whatever I type in here, that's where that's going to go. It's going to go in between these two percent signs. So assume this is the query, right? If this is the query, sorry, I need to put quotes here. If this is the query, what we need to do is we need to terminate this search. So the first thing I would do is I would type in close parenthesis. This close parenthesis will likely get inserted right here, which would make it look like this. Now this isn't a valid command. We need to continue moving. We need to continue with this, but that's what it would make it look like. From here, what I'll do is I will imagine the query that I would want it to be. So I would want it to be match all the users, whatever. What I'd actually want to do is actually terminate this and run a second query. and see if it would combine everything together into one list. And so I can say select star from, so this isn't select star. This is probably like select name and profession. I'm going to make this wider. So this is probably select name and profession from users where name is this. And then I'm going to run a second query here. I'm going to say select star from users. And then I can just close parentheses. I can just end it there, right? The problem though is that I still have this remaining bit, and I need to terminate this because if I don't do anything with this, it's going to create an error. There's a couple ways you can do this. One is you can try doing a comment. The way that you do a comment is that it's just 2 dashes. So I can try doing this. It may or may not work. I want to give this a shot. But what this is basically doing is it's going to, the first query is going to get the name of the profession from users. And this will match, I don't know what this will match. It will match something. I assume everyone. And then I'm subsequently saying select star from users. So this is going to get every user in the database. And not only is it going to get the name and the profession, it's going to get their password in theory. So this is the part that was is the user input that I need, because this component, the percent quote semicolon, was part of the original, and then the rest of this was part of the original. So let's start by entering this in and see what we get. All right, so off the bat, what I can see here, well, I guess it worked. Off the bat, what I can see here, these are all the results of that first query. So this is getting the name, the profession, where the name is matching Wildcard. So that's going to match everything, right? And then secondly is the command where we're going to get not only the name and the profession, but we're going to get all of the fields from the users table. And then this is a comment so that this stuff does not trigger an error. And if I scroll down here, you can see the rest. So you can see here, we have a name. This is the profession. Given that this looks like a password, we have the gray blob here. I assume this column is the password. And then this fourth column here looks to be like a username. And then you can see it's got some sort of error here afterwards. But this all executed properly. So I know this is a little bit confusing. I'm going to start answering some questions here. Please, if this seems like black magic to you, please ask, because it's very difficult to keep in mind what component is being inputted by the user and what component is being included by the program that the server is running. We can't see that. We don't know what that is. So there's a little bit of a challenge here to understand the difference. So Nick is asking, do the 2% signs represent name and profession? No. The 2% signs, what they represent is the wildcard. So the percent sign means that it can match 0, 1, or more characters. And so the reason why there are 2% signs is that whatever the user types in is going to be sandwiched in between the 2% signs. If you don't have a percent sign on both sides, then if the user typed in A as the example, then if there's a percent sign only at the end, if there's only 1% sign at the end, then it will only match anyone whose name started with an A. And if there's only a percent sign at the beginning, then it would only match people who have A at the very end of their name. And so you need the 2% signs, one on either side, because that will allow any number of characters on either side of the A. And so this will match any person with an A, someone in their name. All right. Kyle is asking why does this get the result? Why does it get the results for the people twice and not once with the password information in it? This is because when we run the query, um, it's actually two. The first one is the normal query, which is being executed when the search is being run, and then the second query is us specifically trying to get all of the results. Okay. Um, Michael's asking, they're getting a SQLite error near percent sign syntax error. Why is there a syntax error for the last wildcard in the quotation marks? Um, I can't really give you much help with this unless I have to look at your specific command. It's kind of hard to gauge, but I would make sure that you're not missing any of these characters from this example here. What I'll do is, for everyone's convenience, let me just make sure I got this right. I'm gonna post this in the chat. That's the official way that you can do this very quickly. Hopefully that helps you figure out what you're doing wrong, because it's very hard for me to guess what you might be doing wrong without seeing it. Chris is asking, how do we get the SQL from the website? How do we get into the SQL from a website where we are not already in their SQL? Gonna have to unpack this question a little bit. So we do not have direct access to the SQL database right now. What is happening is we are typing in input, and then the software on the server is taking our input and it's adding it into its query, and then it runs that query on the SQL database. So even with the SQL injection, we are still not getting direct access to the SQL database. We are simply modifying the query that the server is sending to the database. And the way that you get access to this in the first place, that's kind of what I mentioned at the beginning of the demo, is you would look for any ways that there's user input. So search bars, login pages, those are probably going to be your two most common places. You might also find one in like if there's like a form for like leave us a comment or like open a support ticket, that might be a way to find a SQL injection vulnerability as well. Nick is asking, what's the best way to determine which database a website is using? The best way to do that is to trigger an error. That's the best way to do that, because sometimes in the error message it will tell you. And so as an example, I think if I just do this, at the bottom here you can see the error, and it says error SQLite error. So now you know that the database I'm using is SQLite. Ways that you can trigger errors: enter in single quotes, enter in single quotes, enter in double quotes, enter in semicolons, enter in the dashes, the two dashes. Try to enter in as many of those different things as you can. If they aren't doing proper proper filtering and sanitization of your input, it's very likely that one of those things will trigger an error. Gil's asking, are we entering the SQL command in the space on the website? Yes. So you can just copy and paste exactly what I typed in there and enter that into the search bar and then just hit search. So as an example, I'm going to do this again. This is exactly what I typed in here. I just hit enter and there are all of the results. All right. So I'm going to start a poll. And we're gonna ask what topic do you all what topic are you all interested in? We've come kind of to the end of time here. We're a little bit over, but we want to know what topics you're interested in learning. Next episode, we're going to be covering how to solve Pandora in the gym. So that is specifically about how do you reverse engineer a network protocol and solve the challenges based on that. So that will be the next episode. I'm going to also figure out whether you all would want to learn how DNS works, how to stop SQL injection, and I'll add another one in here. How does ping work? We have a blog post coming up in the next couple of days, which is all about pings. And if anyone else has any other suggestions for different topics, please ask us in the chat. I can add more options in future polls. But with that, I'm just gonna let this poll run here. Thank you all for joining us again today. Really appreciate having you all join here. We have over 80 people who joined us live. So tune in again this same time next week. We're going to be doing this next Thursday, again, 5 p.m. Eastern. We're going to be covering how to solve Pandora in the gym, answering your questions about network traffic. And with that, enjoy the rest of your day, and we'll catch you again next episode. And remember, NCL registration, regular season registration, regular registration ends tomorrow, 11:59 p.m. Eastern. So if you don't register by then, it's going to cost you an extra $10 for a late registration until Tuesday. So make sure you sign up, get your friends to sign up. Don't miss out on this new season. There are going to be a lot of fun challenges. We're really looking forward to it. Preseason starts on Monday. And with that, we will see you in the next episode. Thank you very much for joining us.